This is the code used. There are two codes, this one and this. We first run this initialize constants integrator, and then we obtain two graphs. This one is for how the aileron, tail, and radar and two throttles of engine behave. So here x under x, we have given inputs for uh, for the nine states. The velocities, pitch, yaw, and roll rate, and their angles. Under U, the inputs which are given is for aileron, tail, rudder, and two throttles. So we run this and we get two graphs, and this shows how aileron behaves and so on. The same is simulated in the Simulink. So as I said, under X there are three velocities. Velocity in north direction, east direction, and the third one is height. And there is roll rate, pitch rate, yaw rate, and phi theta psi. These are angles. And so so to see the velocity, I've given a scope over here, which is scope 5. And after we run, we get the we get the we get the maximum velocity. So we have inputted in the code saying x is 85. So it starts from 85, and the maximum it's reaching is 175 or 177 velocity, and the constant speed it's maintaining is 150. I can say it like that. And then to see the roll rate, pitch rate, and yaw rate, after we run the Simulink, we have attached another scope. So this is how it comes, and the height in which it's traveling is maximum is 2000 feet, and it's varying, and I've given a scope for that. So maximum height is 2000 feet, and we are assuming this model is in northeast direction, and velocity is initial velocity is 85, and maximum it is reaching to 175. And there is a limitation. The aircraft won't deflect above 25 degree. So we can input the aileron tail, rudder, and two throttles here. So what we give the input here is not time varying. After we run, the aircraft will perform in the same according to the same input. But when we want to change in some when we want to change the pitch rate or the angle at a particular time, we go to Simulink, and I've given here. So this is pitch rate. So at 20th second, I have given 10 degrees of deflection, and I want it to sustain I want the deflection to sustain for 5 seconds. So I have given after 25th second to come back to the normal, that is minus 10. It is coming back. So for a sudden deflection and for a certain period, we can input here, and and the constant value it's performing we have inputted in the code. So we run this code and we get two graphs as I said, and we run the Simulink. At 20th second, it performs 10 degree or 10-degree pitch. And at the same time, we can see through scope how the roll pitch yaw rate is varying. We can verify the inputs we have, what the inputs we are given, if the aircraft is performing according to that. And as I said, the aircraft, we are assuming the aircraft is performing the maneuver in the northeast direction, and the height velocity that started at 85. So that's it. And we have a sudden spike over here. That is because in the Simulink model, we have inputted here at particular second how much deflection we need.